गुड आफ्टरनून ऑल ऑफ यू। हमने जो है पिछले लेक्चर में बायर विलीगर ऑक्सीडेशन मॉलिक्यूलर रीअरेंजमेंट रिएक्शन डिस्कस किए थे। ठीक है, आज जो है हम न्यू नेम रिएक्शन डिस्कस करेंगे, शैपेरो रिएक्शन। ओके, बहुत ही फेमस रिएक्शन है शैपेरो रिएक्शन। नेट सेट गेट और सभी फॉर्मेट में जो है इस पर क्वेश्चन जो है पूछता है एग्जाम में। ठीक है, शैपेरो रिएक्शन। सो फर्स्ट ऑफ ऑल उसका जो है हम स्टेटमेंट डिस्कस करेंगे, व्हाट इज शैपेरो रिएक्शन। ठीक है, नाउ लिसन केयरफुली। कन्वर्जन ऑफ कार्बोनिल कंपाउंड, conversion of tosyl hydrazone of carbonyl compound into olefin in the presence of excess strong base called as Shapiro reaction. Now listen carefully. Conversion of tosyl hydrazone of carbonyl compound into olefin in the presence of excess of a strong base called as Shapiro reaction. Shapiro reaction means simply conversion of carbonyl compound into olefin. Now look here, this is carbonyl compound. Okay, firstly it condensed to form tosyl hydrazone. Okay, firstly carbonyl compound condensed to form tosyl hydrazone. Okay, and this tosyl hydrazone react with strong organic base. Okay, to form olefin. Simply to form alkene. Okay, or olefin. Okay, so this is the general representation of Shapiro reaction. Okay, now look here, I am taken CH3 C double bond O CH2 CH3. Okay, carbonyl compound. Okay, it is converted into tosyl hydrazone by the reaction of carbonyl compound with tosyl hydrazone. Okay, so here I am write the structure of tosyl hydrazone. Now look here, okay, so this is the structure of tosyl hydrazone. Sorry, tosyl hydrazine. Okay, when this carbonyl compound is treated with this tosyl hydrazine to form a tosyl hydrazone. Okay, so here look here, CH3 C double bond N NH TS. Okay, here this TS is stand for this group, tosyl group. Okay, and here NH or here is NH. Okay, and this group, this TS is stand for this whole group. Okay, tosyl group. Okay, now look here, simply here this oxygen of carbonyl group and two hydrogen from this NH2 is removed as a water molecule. Okay, and we will get this type of powder called as two-side hydrazone. This is the two-side hydrazone. Okay. This is the actual substrate molecule of Shapiro reaction. Okay. Now look here the statement. Listen carefully. The conversion of two-side hydrazone of carbonyl compound into olefin or alkene in the presence of excess amount of strong base called as Shapiro reaction. Okay. So simply this is the actual substrate molecule of Shapiro reaction is two-side hydrazone. Okay, and it is formed from the carbonyl compound and two-side hydrazine. Okay, this is the two-side hydrazine. Okay, this is the structure of two-side hydrazine, and by the reaction of both carbonyl compound and two-side hydrazine, a two-side hydrazone is formed, and it is the actual substrate molecule of Shapiro reaction. Okay, this two-side hydrazone further react with strong base. Okay, to form an alkene. Now look here. Okay, so this is the alkene is formed as a major product in Shapiro reaction. Okay, here strong base is used. Okay, generally here organic strong base is used. Okay, like N-butyl lithium, also methyl lithium is used as a base in Shapiro reaction. Also LDA is used as a base in Shapiro reaction. Okay, so mostly N-butyl lithium is used as a base in Shapiro reaction. Okay, and here also hydrolysis takes place. Okay, and after the hydrolysis a alkene is obtained as a major product or final product of the Shapiro reaction. Okay, now look here, the conversion of hydrazone of two-side hydrazone of carbonyl compound into alkene or olefin in the presence of excess amount of strong base is called as Shapiro reaction. Okay, so this is the general orientation or representation of or general reaction of Shapiro reaction. Okay, now the second point is in Shapiro reaction kinetically stable control product is formed. Okay, we know that there are two types of product is obtained in alkene. First one is kinetically controlled product as well as thermodynamically controlled product. Okay, so what is kinetically controlled product and thermodynamically controlled product? Now look here, I am write this type of alkene. Okay, and also I am right here this type of alkene. Okay, so which alkene is more stable from both? Okay, and why is more stable as compared to each other? Now look here, this is our alkene group. Okay, here one proton is present. Okay, and on another hand one substituent is present, methyl group. Okay, in this case. Okay, and here now look here, one proton is present, also here one proton is present in this alkene. Okay, but in this alkene, suppose here I am indicated A alkene and here I am indicated B alkene. Okay, so in the case of A alkene, one substituent is present, okay, as compared to B alkene. Okay, so the alkene is more stable which have more substituent. Okay, so here B alkene have substituent as compared to B alkene. So A alkene is more stable than the B alkene. Okay, so this type of alkene is called as thermodynamically alkene. Thermodynamically stable alkene. It is major alkene. It is more stable alkene because of more substituent. Alkene is more stable. Okay, so here one substituent is present as compared to B alkene, so it is more stable alkene, and it is also called as thermodynamically stable alkene. Okay, here only proton is present as compared to A alkene, so it is less stable alkene. Okay, B alkene is less stable alkene. Okay, and it is kinetically stable alkene. It is called as kinetically stable alkene. Okay, so clear है. Okay, kinetically control alkene और thermodynamically stable alkene किसको बोलते हैं? मोर सब्स्टिट्यूएंट alkene है वो मोर स्टेबल रहेगी, और उसी को क्या बोलेंगे? थर्मोडायनेमिकली कंट्रोल स्टेबल अल्कीन बोलेंगे. और जिसमें सब्स्टिट्यूएंट कम है, लेस सब्स्टिट्यूटेड अल्कीन रहेंगे, उसको लेस स्टेबल अल्कीन बोलेंगे, और उसी को क्या बोलेंगे? काइनेटिकली स्टेबल अल्कीन. ओके, सो इन द केस ऑफ शापायरो रिएक्शन द रिजल्ट विल बी ऑब्टेन्ड एज अ काइनेटिकली स्टेबल अल्कीन. ओके, जो अल्कीन हमको शापायरो रिएक्शन में मिलेंगे वो क्या रहेंगे? काइनेटिकली स्टेबल अल्कीन रहेंगे. ठीक है, ये होगा सेकंड पॉइंट. थर्ड पॉइंट क्या है? द स्ट्रॉन्ग ऑर्गेनिक बेस इज यूज्ड इन शापायरो रिएक्शन यूज्ड एज अ टू इक्विवेलेंट मॉलिक्यूल. ओके, इन शॉर्ट टू मॉलिक्यूल ऑफ बेस और टू इक्विवेलेंट ऑफ स्ट्रॉन्ग बेस इज यूज्ड इन शापायरो रिएक्शन. ओके, दिस इज द थर्ड पॉइंट. नाउ द फोर्थ पॉइंट इज add the alpha position of carbonyl compound. Okay, now look here, this is the carbonyl compound and this is alpha position and this is alpha position. Okay, so add the alpha position of carbonyl compound or add the alpha position of fusyl hydrazone which is formed from the carbonyl compound. Minimum at least one proton must be present. Okay, जो कार्बोनिल कंपाउंड है और टुसाइल कार्बोनिल कंपाउंड है हमारा या टुसाइल हाइड्रोजन है, उसका जो अल्फा कार्बन है उसके पास एटलीस्ट मिनिमम एक प्रोटॉन प्रेजेंट होना. ठीक है, यहाँ देखो, यहाँ हमारे पास दो प्रोटॉन है अल्फा पोजीशन पे और यहाँ पर तीन प्रोटॉन है. यहाँ पर भी दो प्रोटॉन है, यहाँ पर भी तीन प्रोटॉन है. एक तो कार्बोनिल कंपाउंड या कार्बोनिल कंपाउंड से जो टुसाइल हाइड्रोजन कंपाउंड फॉर्म हो रहा वो दोनों के पास अल्फा पोजीशन पे एटलीस्ट एक प्रोटॉन तो प्रेजेंट होना. वही कंपाउंड क्या करेंगे, वही सबस्ट्रेट मॉलिक्यूल क्या करेगा? शापायरो रिएक्शन शो करेगा. ये हो गया चौथा इंपॉर्टेंट पॉइंट. ओके, सो दिस इज ऑल अबाउट द इंट्रोडक्शन एंड जनरल रिप्रेजेंटेशन ऑफ शापायरो रिएक्शन.